Hello YouTube. In the previous video I used my milling machine here as a workshop press and pressed in that bushing there using the spindle, and because of that the spindle seized up here and stopped rotating, and I did that because I am an idiot. Of course one should not do that, but actually I have given it a few whacks up here and it seems to have released it so much that it is actually rotating again here. So maybe I should just continue using it like it is. Or not. No, of course I have to change the bearings here. There are two tapered bearings in here. It's like a wheel bearing kit. One down here and one up here somewhere. So on the unmodified version of this mill, and this quill here can go up and down here, and there is a mechanism here that you use it like a drill press more or less, and then the whole quill gone down. But I have locked it here. So if I unlock that, I have a cushion there. And let's give it a few whacks. Coming slowly there. Oh yeah, it is me, of course. It is my own fault. So I think what is stopping it from going down, that is my pulley here for the spindle leg holder, so I have to remove that. That is a set screw. Whoop! Did you see? That was a miracle. There we go. So this will work. It's more than halfway out. Maybe it has something to do with this one, or can you see it? No, I guess not. That is. Ah, it wasn't very tight. It was almost loose. Have you seen? Here is my quill and my spindle and the two bearings. And it sounds like a caterpillar. So there is one of those locking nuts. One of the tabs should be engaged. And now I have 3 hands, of course. Here is a purpose-made tool for it. If I'm lucky, everything will fall to the floor. I have to take it out to my workshop and fix it. So I didn't think it was locked on that washer there, but obviously it was. Oh, the lock was done. Maybe it is here where all the grease is. Yeah, it was. I didn't see that. Maybe I have to get a new washer then. Yeah, so the way this must work is that there is a nut there, an internal nut there, and you can see where one is supposed to hit with a screwdriver. There is really no way other than hit it with a hammer. Here is a hammer. Oh, that was good, wasn't it? I just had to tap it a bit and then it comes here. You never know. Maybe it has been loose. No. There we have it. That's that one. Also a little bit of grease there. Oh, it will all be cleaned up before I put it together. So. And for all of you that have a little bit of a mess in your workshop, you can maybe you're happy now that you can see that one can take a spindle apart even in with the worst disorder ever. No, I don't want to have a steel hammer. I want to have something else. No. I need something better. I need a press. The milling machine? No, we don't go there. I need a workshop press. I will build a workshop press. Yeah. I think I can start like that. An improvement would be to have it run much faster. Contact! Ha ha ha! It works! It actually works! How convenient! And that tonometer up there, it says almost 0 actually. There's no force at all. So that is the tonometer. Well, I think I will drop it on the floor in a little while here. Oh! This is the one that probably failed. Ah, here it comes. It says here 3307 P5. Aha, P5 actually. So P5 is a quality class for low noise and well running bearings. And this one, can I get this one off there? Or what can I do with that one? And shove in a screwdriver there, maybe that works. Just will explode. That's what happens here. With two thinner bars so I could get under the bearing correctly, then I got it loose. And the bearings I have is this one and this one, 33009 and 33007 P5 class, and that's a little bit of a pity because these two bearing types, they are not so common and there is a bit of a problem to find them. And see if I can get the outer ring out there. What is this? Oh man. And I made tools for this and then it just pops out like that. Oh, it isn't fair. And there is a little bit of rust. Now the other side then. So if you look in here, it is really difficult to come in with something. But I bought this tool and you know how really worthless they are. They're really difficult to work with. And I can already now see that I cannot get in there. No, it sits tight there. With a little bit of luck I should be able to get that in there. So I could get the ring out, but I don't think that we can see what's going on. Perhaps you can see the claw there. Anyways. And then it's just to tap it upwards. Here we go. There it is. Yeah, so that is what the tip looks like. I had to make it pretty pointed there. This is what it looks like original. But it was just the first millimeter or so. So once there was a gap, then I could get in there properly. and there is now really a proper grip on this one, but it is out. And a final view of my little contraption here. So this is a cone that prevents the claws from going apart or going inwards. I got 2 bearings, but boy, they were not easy to find. This has to be imported from Germany. And it is this 33009. It is refreshingly free from any markings of manufacturer. I hope it works. There's a bit of protection there. And here's the other one. I haven't opened that one yet. I have it, and there is again protection there. Here is at least a marking of MTK, it says. So they were not so easy to find, and I can tell you why. And that is because one do not design machine spindles with those bearings. So these are wheel bearing units, and this is designed as a wheel bearing spindle. So I will just take the consequences of that and call this a wheel bearing spindle instead of a machine tool spindle. So for this wheel bearing spindle, the first thing to do that is to press in the outer ring here. It should go in there. That is the one that was so difficult to get out. Let's see if I can use the press for that. And there. I need something else to push with. Feels like it is going in nicely there. And I'll now get to press out that ring there. There it is in bottom. And I see on the tonometer there that it is in bottom there. I have to get this one out, and that's good. Yeah. So the next thing is the inner ring and the roller set should go on here, and that has to be pressed on. And there it is in the bottom. This works brilliant. I should have built a press much earlier. And that ring should just fall in there, right? Oh, I think it needs a little bit of persuasion there. I'll try with this one again. It worked. So now this is a wheel bearing spindle. So I now have this grease. This is wheel bearing grease. I didn't want to have this, but I saw the grease I wanted in a shop, and I went there, and when I came there, they have this one. Yeah, so it is this one. So it is alright, but what it doesn't have, it doesn't specify that it's performance in vertical position. Otherwise it is good for low to medium speed, pretty high temperatures. and other good things. So I will probably fill it up too much or I will probably fill it up too little. You never know. This is with a lithium soap in it, extreme pressure additives, EP additives. So I think it should be alright. Can I now lower it? Yeah, I should be able to do that. Oh, I need a tube. Well, it didn't take long until I wanted to come up with shortcuts. Let's see how this works. Looks right there. I may need a vise for this. So it is now tight. How tight? I really don't know. I had to press it down, so there was quite a bit of force there. So of course there is too much grease in it, so I will install it in the spindle and start to run it in. Oh, it's in a bit. I have searched and searched for that stop screw that was there. It is an M10 stop screw. I went back to the recording. Yeah, there definitely was a screw, but I really cannot find it. I have looked everywhere. I was about to clean up the whole workshop, but I had to draw a line there. That was simply too much. In the recording I could see that there is a void there. There is an empty space between that outer shell here and the inner shell. And I have to look there. Can you see them? There are actually two of them. One is enough, but there they are. So it's not to press up, but to have a controlled way to lift it. That's really the point there. I will fix that stop screw there right away. There it is in that groove. Not sure exactly where the problem is. It was stuck here because the splines there had to go in right there. It's difficult with a good shot there, but maybe you can see it. I used my nose there for autofocus on the right area. Anyways. So hopefully it should just be to lift it up now. This now goes easy. Can I do it by hand? Yeah, I can do that. I can even do it like that. And there it is in place. And the stop screw. Amazing, I could do it. First test, watch out here, that one should rotate, and that spline shaft there as well. Well, at least it didn't explode. That was good. Let's do double speed there, but after that I need to go and check the instructions for how to run in a new bearing. That's better. Nothing is warm, of course. If it had been warm now, that would have been a catastrophe. Anyways, it's getting late again, so I will continue tomorrow. It is necessary to run in grease lubricated bearings. So this will take time, so I don't think I will show this. Maybe if something interesting happens. So I am at 1800 RPM and the spindle gets pretty hot only after 2 minutes of running here. Yeah, you can see the grease finding its way out here. I will have to continue that, so I have an automated program for this. It took the whole day to come here, and that was because I had such copious amounts of grease in that lower bearing there. Can you see the glitter? All the small particles that are here, that is grease particles. Everything here has been sprayed with grease that has come out of the spindle. So it took the whole day to come here, and I started low, 800 RPM, ran that for 2 minutes, and there was a tremendous heat build up here, so much that I couldn't hold my hand there. Maybe, so I think it was on 60 degrees. So I stopped, waited for 10 minutes, started, ran until it was too hot again, waited 10 minutes and kept on doing that, and after a while, yeah, the heat build-up was fine, no problem, and then I increased the speed to 1200 and gradually increased up to 3200, and when I was at 3200 I could run that for a few minutes, but then certainly there was a sudden heat generation spike again there. I think there was a grease blob that came into the bearing, so I kind of had to restart that. So the whole process, a full day or even more, but I'm here and I think it works fine. It actually runs just as easy as the old one did, I think. The biggest resistance here is from the gearbox right now. So I call this a wheel bearing spindle, and I think it's fair to do that because this isn't designed as a real machining spindle should be designed. A bearing manufacturer's view on this is that one do not use tapered bearings in a machine spindle. It is only angular contact bearings and cylindric roller bearings. I will link to a document about super precision bearings. It is of course about the bearings, but there is a chapter called Design Considerations, which is a complete guide to how you design a spindle. And all aspects of it, how bearing arrangement, bearing combinations, stiffness, everything. So if you like to know how a spindle should be designed, well, go there and have a look. Okay, so trying to wind down from my wind down speech there. I still have a few things to do, especially around the locking nut there, so I will need to take this down again. But you know, this is really easy now. Loosen this screw here, that stop screw there, and take off the encoder I have on the top of the spindle axis, and it is just to take this down here. And to put it back, it is just to do the opposite, just make sure that the splines on the spindle axis are aligned with the gears. So it has been far too much talk here in the end, so let's just call it quits. Thank you for watching.